Most probably we discussed the hormones, local hormones of the GIT, the individual gastric juices, gastric individual digestive enzymes we discussed, bile we discussed also to some extent. Next, the main thing that remains, digestion of carbohydrate, protein, fat. Is it clear? Name of the digestive enzymes we must know. Huh? What are the enzymes of carbohydrate digestion? What are the enzymes of fat digestion? Enzymes of protein digestion? That we should know in details. There is no mercy in this matter. Okay. So enterohepatic circulation we discussed. Let us come to the point. Protein digestion. Carbohydrate digestion. Enzymes of carbohydrate digestion include salivary alpha amylase, pancreatic alpha amylase, salivary alpha amylase secreted from salivary glands. There are three pairs of salivary glands in the mouth. They are parotid, submandibular, sublingual. From these glands, salivary alpha amylase are secreted. Pancreatic alpha amylase secreted from pancreatic juice, exocrine. It is secreted in exocrine secretion of the pancreas. Okay, pancreatic amylase. Then next, disaccharidases. Disaccharidases, these are secreted from saccus enterica, from intestine. These are the disaccharidases are the constituents of intestinal juice. That means saccus entericus. And disaccharidases include maltase, isomaltase, sucrase, lactase. Okay, this is old study, nothing new. Next, uh, these are the enzymes of carbohydrate digestion. Then come to the process of carbohydrate digestion. Carbohydrate digestion starts at mouth. So, though the period is very brief, enzyme responsible is salivary alpha amylase. The salivary alpha amylase hydrolyzes alpha 1,4 glycosidic linkages. Alpha 1,4 glycosidic linkages. Okay? Glycosidic bonds. The glycosidic bonds, these are of two types. Alpha 1,4 glycosidic bond that is hydrolyzed by salivary alpha amylase. In fact, the pancreatic alpha amylase is also responsible for hydrolysis of the alpha 1,4 glycosidic linkages. Okay, then come to the point. As it is still food in the mouth, salivary alpha amylase is acting on it. The salivary alpha amylase hydrolyzes the carbohydrates into maltose, very small quantities of maltose and maltodextrin is formed, and most of the carbohydrate that is are alpha limit dextrins, alpha limit dextrin. Okay, these are the intermediate products of carbohydrate digestion. Okay, very few maltose is formed as a result of hydrolysis by salivary alpha amylase. Then the food is pushed to the stomach where salivary alpha amylase becomes inactive because of very low pH. Because of very low pH, that means because of high acidity. High acidity. In fact, the mixing action it takes place in the stomach, and as a result of this mixing, acid chymes are formed. Acid chyme then passes through the pylorus into the duodenum. Is it clear? While passing through the duodenum, it the stimulates the S cells of the upper small intestine to secrete secretin. Secretin. Is it clear? And secretin stimulates bicarbonate-rich watery pancreatic secretion. Bicarbonate-rich watery pancreatic secretion. Okay. Next. Then, as the food is in the small intestine, the pancreatic alpha amylase, that means in duodenum, the pancreatic amylase is pancreatic amylase enters into the duodenum, second part of the duodenum, so the common bile duct. Common bile duct is formed by uh, cystic duct and pancreatic duct. These two ducts together constitute the common bile duct. Is it clear? This that ultimately enters into the second part of the duodenum. Here, this pancreatic juice containing the alpha amylase uh, acts again acts starts acting on carbohydrates, half digested carbohydrates. Ultimately there is formation of more maltose and very few alpha limit dextrin remains. Is it clear? Most of the products of the pancreatic alpha amylase digestion, that means by hydrolysis of pancreatic alpha amylase is maltose, and very small quantities of alpha limit dextrin. Alpha limit dextrin. Alpha limit dextrin means if someone asks you, what do you mean by alpha limit dextrin? It means intermediate products of carbohydrate digestion. Dextrin, dextrose, these are the ultimately the polysaccharides, the intermediate products that is produced, that is called alpha limit dextrin. Okay. Then they are acted on as they are mostly disaccharides. These are acted on by disaccharidases. These disaccharidases are the constituents of succus centricus that secreted from the brush borders of the small intestine, which convert disaccharides into monosaccharides. As a result of their action, the disaccharidases include maltose, isomaltose, maltose, maltase, isomaltase, sucrase, lactase. Ultimately, the final product is glucose, fructose, galactose. These are monosaccharides. Mind it. Glucose, fructose, galactose. Is it clear? Fructose, this is the keto sugar. Glucose, the aldo sugar. Then galactose. These are the end products of carbohydrate digestion. Then there then this monosaccharides are absorbed. It is absorbed by secondary active transport mechanism by sodium glucose cotransporter. Okay, sodium glucose transporter. But fructose, mind, this is the importance. Yeah, fructose is absorbed by it is absorbed by simple diffusion, by facilitated diffusion. Facilitated diffusion. Facilitated diffusion means enzyme mediated diffusion. Is it carrier mediated diffusion? This is called facilitated diffusion. Okay. Next, they are absorbed. Then fructose is absorbed by facilitated diffusion. It is absorbed from the basal side by GLUT4 glucose transporter and other glucose galactose. These are transported by GLUT2 transporters. GLUT2 transporter, glucose transporter 2. There are 5 types of transporters: GLUT 1, 2, 3, 4, 5. Okay. So GLUT2 is responsible for transporting glucose and galactose from the basal side of the enterocytes into the tributaries of the portal circulation, and they are ultimately by portal circulation they are delivered to the liver. Okay, in liver they could be stored as liver glycogen, or it is exported to other tissues. It is exported to muscles, or at the muscles there could be also storage of glucose, muscle glycogen, or they are oxidized for energy. And most important site of glucose oxidation is on notable central nervous system. The central nervous system solely depend for its energy on glucose. Glucose is the source of energy. It is the glucose is the fuel for the central nervous system brain. Is it clear? It cannot utilize those fats or those amino acids. Okay. Next, there is definitions of the secondary active transport. This definition of secondary active transport we taught you, but I like small definitions. Here there are definitions. These definitions, if you can say good, if you cannot say, the very small effective definition is we are coming. Transport of substances coupled with passive diffusion of another substance can be termed as secondary active transport. Is it clear? Understand. Try to understand the in between the lumen of the intestine and enterocyte. As the lumen of the intestine, this is part of extracellular fluid. Naturally, sodium will be more there. So sodium, as it is, concentration of sodium is more in extracellular fluid. I mean, in the lumen, it will try to enter into the cell, because in cell, within the cell, the concentration of sodium is less, but the barrier is semi-permeable membrane. Okay, the semi-permeable membrane don't allow it to do so. But when it binds with some transporter or with some co-transporter, that means sodium glucose co-transporter. This sodium glucose, when sodium comes in contact with this transporter and glucose is also available, then it becomes, when both are available, then it becomes operative within fraction of second. It takes because of the gradient of sodium, it enters into the within intestine. Is it clear? It is within. So glucose is within these enterocytes, from where it is ready for transportation to the portal through the portal circulation to liver. Next, what about glucose? What about sodium? The sodium is uh, transported by potassium ATPase into the extracellular fluid. So sodium concentration is kept minimum. Sodium is transported to the extracellular fluid. That means in the lumen. That's why the ultimately the concentration of sodium within the cell is less and gradient is maintained, and this gradient of sodium concentration, gradient means difference of concentration. This difference of concentration is the driving force for absorption of glucose. It is so this is secondary active transport. Is it clear? Transport of substances, that means substances, nutrients and electrolytes coupled with passive diffusion of another substance can be termed as secondary active transport, or you can tell those definition. This definition is uh, transport of substances into the cells utilizing the force of downhill concentration gradient of a second substance established and maintained by active transport of sodium out of the cells. It can also be, and that is a good definition. Okay, another definition. We will not waste much time on this definition, but you try to understand. If someone try understand, if you can remember, that is good. That is good for understanding explanation. Secondary active transport, there is sodium, glucose, several types. Sodium, glucose, secondary active transport, sodium amino acid, secondary active transport. Okay, there are other varieties of secondary active transport. We will not lose time over here. The digestion of lipid. Carbohydrates, though the main bulk of energy, but lipids are rich sources of energy, and the lipids they are as taken in very limited quantities. That's why it is just at least in our country responsible for 30 to 40% of the calorie requirement in Western country. If it is in Western country, this is 30 to 40%. In our country, it is lower. It is about 20 to 25%. Why? Because lipids, these are costly items. Meat, foods of animal origin, these are costly items. Common people cannot afford it. Is it clear? That's why in a mass they supply less energy. In Western countries, it can supply up to 40%, and in countries like us, it supplies about 20 to 25% of the calories. The energy extraction from protein is complex, and proteins energy consumption from proteins, high energy consumption from proteins is not good for the body. That can lead to in long term some diseases that we are not discussing at this stage, but this is the at this stage you can remember that energy extraction from fat protein takes longer time than carbohydrate. It is also not simpler as carbohydrate. Okay, it is biological membranes are this is constituted of lipids, and the main lipids structural components of lipoproteins. Then again, cholesterol, steroid hormones. These are the precursor. And precursors, cholesterol is the precursor of bile acids, steroid hormones. Prostaglandins, leukotrienes. These are also obtained from uh, 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 these are obtained from 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 uh, from this uh, this is from this uh, essential uh, essential lipids, that is that is your uh, that is arachidonic acid and leucot arachidonic acid and uh, that is linolenic acid and arachidonic acid. These are the essential lipids. Okay. Dietary lipids: triacylglycerol, cholesterol ester, phospholipids, free fatty acids. Uh, Sources of the dietary lipids, beef, mutton, egg, milk products, whales, butter, cheese. These are even vegetables. In vegetables, there could be some the lipids. Okay. Next, next, requirement of lipid digestion enzymes. For lipid digestion, two important, broadly we need two requirements. Number one, enzymes. Number two, bile salts. What enzymes are required? Lingual lipase, gastric lipase. These two are acid stable lipases. Then pancreatic lipase, uh, coming from pancreatic, exocrine pancreatic juice. Polypase, it is also from pancreatic juice. Cholesterol esterase, cholesterol ester hydrolase, phospholipase A2. Okay. Bile salts, naming of the bile salts that we are not going in details. Sodium, potassium, salts of bile acids. In short, that will be covering like this. Next, that will not be required. Next, we come to process of lipid digestion. Lipid digestion starts in the stomach. Enzymes responsible are acid stable lipases. Lingual lipase secreted from Ebner's gland mixed with saliva is responsible for hydrolysis of uh, butter, fat, or the fats, uh, the short chain fatty, short medium chain fatty acids. Is it clear? They act on butter, milk, fat. They can act in acidic medium. That's why they are called acid stable lipase. And gastric lipase secreted from stomach. They are responsible for 10 to 15%, 10 to 20% of lipid digestion. Very less, but though less, very significant in babies, infants, babies. Okay, because they cannot take those beef, meat by their mouth. It's clear. So milk is the staple food for infants, for digestion of milk or milk products or this butter. These are the The lingual lipase, gastric lipases are important. They are again important when there is any disease of the pancreas. In that case, that can be lingual and gastric lipase secretion can be increased. Don't worry for percentage. Your percentage will be given. Okay, by Dr. Mujibur, he is giving your percentage, but the number is very less. That is the thing. Only 61 students. This is very less. Formation of acidic chyme in the stomach. We mentioned acid-rich chyme enters into the duodenum. Here, this acid-rich chyme stimulates secretion of secretin. Secretin, the the bicarbonate-rich pancreatic secretion neutralize the chymes and brings the pH to uh, towards the neutral range and also the alkaline range. And this at this alkaline pH, it is helpful. The, the intestinal lipases can act. Okay, affected into this pancreatic lipase and intestinal lipases can act. They act in acidic in alkaline medium. Most of the enzymes favor to act in alkaline medium, excepting one accepting three enzyme. Number one, pepsin. Number two, lingual lipase. Number three, gastric lipase. These three enzymes uh, act efficiently in acidic medium. Other enzymes mostly acts almost act by in alkaline medium. Okay, next we already mentioned it. There is no requirement of mentioning this. Ultimately, the products of fat digestion will come. Then products of fat digestion, fatty acid, 2-monoacyl glycerol, cholesterol. These are the products of fat digestion. These short and medium chain fatty acids are transported by portal circulation to the liver. The long chain fatty acids, these are monoacyl glycerol, 2-monoacyl glycerol, cholesterol. These are transported by forming micelle. It is mentioned like this. Micelle. The micelles are disc-shaped amphiphasic molecules consisting of products of lipid digestion and fat-soluble vitamins encoded by bile salts. Transport of micelles through the unstirred water layer occurs, then absorption of the products of lipid digestion takes place by simple diffusion, leaving bile salts in the lumen, which are ultimately after its work when it finishes work, is reabsorbed in the terminal ileum, forming enterohepatic circulation. Okay. Within cells, enterocytes, there is again formation of triacylglycerol cholesterol esters. Triacylglycerol cholesterol ester, fat-soluble vitamin, cholesterol, phospholipid, coated by lipoprotein, apolipoprotein A. Is it clear? The chylomicrons then first start their journey in lymphatic channels, then through the systemic circulation to peripheral tissues. After supplying the lipids to peripheral tissues, they ultimately pass to the liver. Okay, as chylomicron remnant. chylomicron remnant. Okay, we mentioned already this protein digestion. Do you know what are the proteins? Beef, mutton, poultry, eggs. Okay, pulses, even second class proteins we should mention. Pulse, vegetables, they are the second class proteins. They are second class protein because one or they lack or they are deficient in essential one or more essential amino acids. Okay, proteolytic enzymes include proteolytic enzymes. We can classify endopeptidase as exopeptidase. Endopeptidases include pepsin, trypsin, chymotrypsin, elastase. They are called endopeptidase because they hydrolyze inner peptide bonds. Then come to the point exopeptidases. Exopeptidases hydrolyze peptide bonds close to the carboxy terminal and amino terminal. Carboxypeptidase AB, this is the constituent of pancreatic juice. Aminopeptidase is the constituent of Succus centricus. Okay, they hydrolyze peptide bonds near the terminals, two terminals, carboxy terminal and peptide amino terminal. Then other peptidases, there are dipeptidases, tripeptidases, which act within cells, within enterocytes. Okay, proteolytic enzymes are secreted in inactive form as zymogens. Zymogens are inactive form of proteolytic enzyme. We know this. Okay, we'll be showing how zymogens are converted to active forms. Proteases secreted from stomach. Protease means proteolytic enzyme. Stomach and pancreas, small intestine. Final products of protein digestion include final digestion of amino acid occur in three locations: intestinal lumen, brush border, within enterocytes. Okay, this is the figure that shows activation of proteolytic enzymes. Pepsin is converted to active form. Inactive pepsinogen is converted to pepsin by hydrochloric acid. And when small quantities of pepsin is formed, that small quantities of pepsin can be responsible for conversion of pepsinogen to pepsin. This is called autocatalysis. The same story, almost same story takes place in case of trypsinogen, but trypsinogen is converted to trypsin by enterokinase, not hydrochloric acid. Trypsinogen converted to trypsin by enterokinase. Enterokinase is the constituent of Succus centricus. Small quantities of trypsinogen convert trypsinogen to trypsin. This is called autocatalysis. This is another example of autocatalysis. Then trypsin is responsible for conversion of chymotrypsinogen to trypsin. Chymotrypsin. This should be chymotrypsinogen, and elastase is converted to elastase. It should be made a bit corrected. You know, the E and okay. So this is the arrow should be a bit here. Okay. You see, this is how these proteolytic enzymes are activated. Protein digestion. Protein starts in stomach. Pepsin is the enzyme, and the product of pepsin digestion are uh, products of peptide digestion is produces peptone polypeptides. Protein digestion